mynews.studio.
Picture a lab filled with blue screens. Immune cells engineered to respond to sound waves are moving toward a hidden tumor. Is this where cancer treatment is headed?
Today is June 8th, 2025. Let's dive into what some are calling a turning point for cancer therapy. When you see the speed and scale of breakthroughs, immunotherapy, precision medicine, even these smart immune cells, does it look like cancer is finally becoming manageable for most patients?
The evidence is encouraging. If we start with immunotherapy, since it first got FDA approval in 2011, there have been over 150 approvals. Just last year alone, 17 new ones. But maybe the biggest step is CAR T-cell therapy, now working in solid tumors, not just blood cancers. That's a major development.
Why did people call that the Holy Grail?
It comes down to the difficulty of targeting solid tumors. Blood cancers are more accessible for immune cells, but solid tumors create a kind of barrier, a suppressive environment. So, CAR T working there means more cancers could be treated this way.
And some of these advances sound almost futuristic. Like at USC Viterbi, they've got CAR T cells that switch on or off with ultrasound. What's the real advantage there?
It's about control. These are called EchoBack CAR T cells. With ultrasound, doctors can trigger them to attack tumors exactly when and where needed. In lab tests for prostate cancer and glioblastoma, they did better than regular CAR T cells. This kind of precision also means fewer side effects.
So instead of immune cells working all the time, doctors could activate them only at the tumor site.
Exactly. That level of control hasn't been possible before. It's almost like giving doctors a remote for immune cells.
Let's shift to precision oncology. These targeted therapies are scientists actually starting to tackle what used to be called undruggable targets.
Yes, that's happening. For example, KRAS mutations used to be seen as impossible to drug. Now we're seeing second-generation inhibitors reach trials targeting KRAS G12D, G12V, even broader pan-KRAS or pan-RAS types. That's especially important for pancreatic cancer, which has resisted treatment for decades.
And AI is having an impact here too?
Definitely. Machine learning can analyze tumor samples, spot mutations, and predict which treatments are likely to work or not before a patient even starts therapy. That's a game changer for immunotherapies, where matching patients to the right treatment has always been a challenge.
But are trial results matching the hype? For example, the idea that cold tumors, those without immune cells, could finally respond to immunotherapy. Is that actually happening?
It's a real shift. In March, UCSF data showed that cold tumors can respond just as well to checkpoint inhibitors as hot tumors. That means immunotherapy could be an option for many more patients, and the process could move faster with fewer requirements.
And in terms of outcomes, there was that single-arm trial in small cell lung cancer with almost an 89% response rate. And for non-small cell lung cancer, a new therapy took median survival from around 10 months to 24.5. Those are major improvements.
They are, and the diversity of new treatments is worth noting. In 2024, we saw the first TIL therapy for advanced melanoma, the first TCR therapy for a solid tumor, and the first IL-15 agonist for bladder cancer. Immunotherapy is no longer just one approach.
Combination therapy is another trend, using chemo, immunotherapy, radiation, and TGF-beta blockers together. Is this leading to more personalized approaches?
Yes, and personalized cancer vaccines are a perfect example. These are made using the mutations unique to each patient's tumor, training the immune system to target only those cancer cells.
So with all these new options, what's holding things back? Why aren't these therapies available everywhere?
The main barriers are access and cost. These treatments are expensive, and many countries don't have the infrastructure or resources. There's also a shortage of trained specialists, and regulatory approvals can be slow. All of this creates big differences in who can get these therapies.
So how are organizations and policymakers reacting?
Groups like the World Economic Forum are encouraging technology sharing, local manufacturing, and faster approval processes. There's also a push to lower prices and expand early cancer detection, especially in lower-income regions.
But as more options become available, doesn't it get harder to choose the best treatment for each person?
It does. In 2025, the range of choices means treatment selection is more complex than ever. AI and advanced diagnostics help, but for many oncologists, it's still a challenge to pick the optimal therapy.
So just to wrap up, immunotherapy is standard for more than 30 cancer types. We're seeing new methods, smarter immune cells, and more personalized treatments. AI helps guide decisions, but access and treatment selection are still obstacles.
The direction is promising. Cancer could soon be managed for millions, rather than being seen only as a fatal diagnosis. But there's still a lot to be done.
That's a look at how cancer care is evolving. Thanks for joining us.
This episode was brought to you by mynews.studio. You can try it out for free.